Hello, everybody. So we're here to talk about taking control of your identity with Keycloak. So a little bit about us. My name is Aaron Hanson. I'm a senior DevOps engineer.
Kirkpatrick, DevOps consultants. We've been using Kubernetes in production for many years, both on-prem and in the cloud.
So we've gotten asked this question a few times in the past day. So just up front, we are not developers of Keycloak, nor do we work for Red Hat or IBM. We are just users of Keycloak, and we love the product and are very passionate about it. So getting into things, what are we going to be demonstrating today? So a few of the features of Keycloak that we're going to go over is federation with Active Directory and LDAP, adding authentication to applications that do not natively support authentication. So you think of things like Prometheus, right? You set it up, you go to a URL, you're already logged in, you can view whatever, which isn't the most secure. We also will cover adding authentication to applications that already support authentication, like OIDC, Oauth 2, and SAML 2. And then we will also talk about authenticating Kubernetes itself with OIDC, multi-tenancy and how it is themable, and using multi-factor authentication for free. So firstly, what is Keycloak? Keycloak is an open source identity provider. It supports single sign-on via Oauth 2, OIDC, and SAML 2, and it allows federation with Active Directory and LDAP. It is multi-tenant and it is themable. It allows for multi-factor authentication, and it is enterprise grade. It was originally created by JBoss, who was bought by Red Hat, who was bought by IBM. So it is now an IBM product. So the first thing we're going to talk about is Keycloak realms. So what is a realm? Each realm represents a tenant. It allows for separate users, separate RBAC, separate federation to external identity providers, separate themes, and a unique admin web console. So over here, we're going to take a look at a realm. So this is a typical realm setting. In the top left here, you'll see a little drop down that has your different realms. Your master realm is used to manage all of your other realms. And you can set up multiple realms that federate to different identity providers and allow for different groups of users to be ingested. So outside of realms, we have the concept of clients. Client provides a single sign-on for an application or service, and it allows for custom mappers for JWT tokens, and it maps groups and roles as needed. They also support OIDC and SAML, and they secure authentication to only known URLs. So within our Keycloak, we're going to go look at clients, and we've got quite a few clients set up here. But for the sake of this demonstration, we're going to take a look at Grafana, just because that's one that we set up. So within Keycloak, this is what you would typically see for a client. Down here, we have our valid redirect URLs, which are the URLs that we're allowed to redirect to while authenticating. In this case, this is our Oauth redirect URL, meaning that when we go to authenticate, it will send us to Keycloak to authenticate, and then back to our valid redirect URL with whatever permissions we assigned ourselves. That is pretty much it for clients for now. So the last thing that's pretty important with Keycloak is the concept of users and groups. Most of you are probably familiar with users and groups already. Users are just entities that can log into a system, and they could be service accounts, applications, or people. And groups provide logical groupings of users, allowing you to map users to roles and attributes. So you might ask, what does mapping a role or an attribute to a user look like? So in the case of our Grafana client here, we have mappers, and we've set up a mapper for the point of this demonstration called roles. The purpose of this mapper is to map our roles from Keycloak to our client. So as an example, if we go to Grafana here, and we take, clients Grafana, and we take a look at our roles, we've got 3 roles set up. We have admin, editor, and viewer. So let's say I wanted to make myself an admin to Grafana. So I would go to groups, and just to kind of give some context to this, let me actually go to the next slide first, and we will come back to this, because this is kind of important. So we'll go over user federation first. So user federation is how we get our users into Keycloak. In our case, we're using Active Directory and LDAP, and we are mapping in users, groups, and attributes from LDAP to Keycloak. And it also supports like automatic synchronization, and it allows for the brokering of passwords using Kerberos. Whoops. There we go. All right, here we go. So this is what user federation will look like. In this case, we've just gotten LDAP set up. So you go in and you can set up like your connection URL, your DN. You can even filter down to specific groups if you want. So like let's say you've got a larger pre-existing Active Directory structure. You can filter down specific realms to specific groups that you want to ingest users from. It also allows you just to test the connection and the authentication, which is really handy. Just gives you a little pop-up that says, yes, I'm working. And then these were the sync settings that I was talking about, where you can set up automatic syncing. So for example, we sync all users once per day, and then we synchronize changed users every hour. And then you can also at any time come to your realm and you can just synchronize all users, or you can synchronize change users. It's really easy to pull in any changes that you make. So we are pulling these from OpenLDAP, which we have set up right here. And within OpenLDAP, we've got a few test groups set up and a few users assigned to those test groups. So I am Aaron, and in my case, I'm assigned to the administrator group. If we look at my group here in OpenLDAP, you'll see my member ID is assigned there. And then within Keycloak, if I take a look at our groups that we've imported, we have our administrator group here, which was synced in through our user federation. And if I look in administrator, you will see that I'm a member of that group here. So earlier we were talking about how I would give myself permission as, let's say, an admin to Grafana, right? So within our client, we have already created the roles. In this case, we have 3, admin, editor, and viewer. Admin is full admin. Editor allows you to edit existing dashboards, and viewer is read-only, essentially. And then under our groups, I've gone ahead and I've set up a role mapping, which basically says that anybody that is in the administrator group that we are pulling in from LDAP is given the admin role. And that is what we see here under client roles and assigned roles. You'll see I've added admin there. So if I come and I look at my user and I take a look at my role mappings and I go to our Grafana client, you'll see that I've inherited the effective role of admin just for being part of the administrator group in our OpenLDAP installation. So this will allow me to authenticate into Grafana as an administrator. So it's very handy to be able to assign roles to different users as you ingest them through LDAP and dynamically set these roles and permissions. All right, and yeah, I think that's actually all I really had to talk about, and I'm going to pass it over to Dan here, who's going to go over some of our use cases and show a little bit more in depth about how these things all kind of connect and play together.
Yeah, for the demonstration here, we're running all of this, just for your information, we're running this all on a Kubernetes installed locally on our laptop. And our goal for this is basically, at our organization, we run the same exact stack in the cloud, on premises in our Kubernetes clusters on-prem, and then also we have the same stack that developers can run on their laptop. So they get the same experience whether they're developing locally or whether they're pushing to their real environments. And that's one of our key marquees, is everything you see here is all running locally, and we've got LDAP instead of Active Directory to mimic the identity provider. But that's this is all a real application. Oops, sorry. Let's do that. So I want to show you 3 primary examples. This first one is Oauth 2 proxy. So this sets up an identity-aware proxy. It's going to know what groups you're in, what role, whether or not you have access to the system. And then with just 3 simple lines to our ingress, which is a Kubernetes. If you don't know what an ingress is, it's a Kubernetes object that tells you how to route traffic into your cluster. But if I'm routing traffic into an app that doesn't have authentication, I can add just these 3 little lines as annotations inside my ingress controller, and bam, I automatically get authentication for free. So let's take a look at this. Let's see here, which one is it? It's going to be, it's not up here. Okay. If I go to Prometheus, if you're not aware, normally you go in and you dump straight in and you see the GUI. There's no authentication whatsoever. In this case, if I come into Prometheus with this thing attached on, it's detected that I don't have a valid token, and then it's redirected me instead to our authentication thing to sign in. So I'll go ahead and sign in. Once I sign in, it forwards me back into Prometheus. And this is what you would normally see if you didn't have this authentication added in. So this allows us to, for developers, if they're working with a remote client or something like this, someone outside the organization, they can expose an app and then before it's fully baked, and then only let the people they want to see it. But yeah, that's, and so we've added that in the same way also to Alert Manager. But if you look at Alert Manager, of course, now that I'm already logged in, it will, since we're using single sign-on, it will detect that I'm already logged in, use that same token, and I don't have to go through the login process. And just to show you that that's real, I can also come back into Keycloak, come to my user, Dan, and sessions, log me out of that session, and now when I come back over to, let's just say, Alert Manager, it dumped me straight back in. It has a cached value of my, it took a cached value of my token. I'm sorry, that's not a great demo, but we'll carry on. But at any rate, where was I? Moving on. Uh-oh. Where did I lose the PowerPoint? There we go. There's the PowerPoint. So that's a case of simple transparent auth to an application that doesn't already support it. You could just as easily use this proxy and attach it onto your app. If your app looked at the token itself and looked at the roles, you could implement all the RBAC inside of your application and be fine with this. There are also, though, libraries that you can incorporate into your own applications that support OIDC, the standard, one of the main standards for single sign-on, out of the box, and give you a more native language-specific authentication path. Both of those will work. And of course, OIDC is also supported by just about any enterprise application that supports single sign-on. The ones that don't will generally also support SAML2, which is an older authentication standard for single sign-on. So basically, as an example for this, we will show you, we've already shown you a little bit of Grafana, but just to log in, Grafana's got built-in support, so you can log in with their native user system, or you can sign in with an external authentication provider. In this case, we've set up this to point to our Active Directory. I click on this, and I'm presented with the authentication screen. I log in, and of course, now I am, I've been given, I think in my case, I am an editor and not an administrator. So I'm not able to create new data sources or do anything along those lines, but I am able to create new dashboards. So that's the authentication for ones that have built-in support already. And then one more we got. And then controlling access to Kubernetes itself. Now, Kubernetes, normally, it's got an API. If you're not familiar with Kubernetes, you use kube control from the command line, and it talks to the API server in Kubernetes. And the API server is usually protected with TLS auth. And the general way most people sign into their Kubernetes cluster is they have a JWT token sitting in their kube config. Well, that JWT token is a bearer token, and it means that if somebody happens to copy that, have access to your local hard drive or whatever, they have access to your cluster all of a sudden. And furthermore, if that person then leaves the company, that token's probably still working, and they may still be able to get access to your cluster. Well, if you wrap it with OIDC, now you can revoke access from users, and you can present a kube config that has no secrets in it, that you can now distribute company-wide, that people can download themselves even from a web page. The way that works, there's two pieces to it. There's first off this kube login plugin, this part of kube that added onto kube control. OIDC is a web-based protocol. So what that means is if you're using a CLI, you've got to launch a web page to basically handle the authentication portion of OIDC. That's what kube login does. It's the local web page to handle the login portion. And then that talks to a second piece that runs inside your cluster, which is a proxy to the API server. Kube OIDC proxy. And you talk to the proxy, it talks to the real API server for you, and that way you don't have a bearer token locally. To show you that, I will go over to my OIDC. First off, my non-OIDC thing, I'm here, and I can do all my things on the cluster, and it happens, there's my cluster. But if I switch to my OIDC authentication one, And now I do the same operation. It's going to bring up the web page, present me with the same OIDC login. I log in. Oops, sorry, I mistyped my password. I think that's why you told me to remember them. Now I'm authenticated. I go back to the command line. This takes a few seconds the first time, but after this completes, you're going to see the nodes. There we go. And after the first time, it's fast each subsequent time because it's already negotiated the token get pod-all. And just to show you all the pieces, again, no secrets under the covers. This is our cluster. We have Keycloak running inside our cluster. We've got the Oauth, the open LDAP for our data provider, and here's our proxies. We've got Postgres running to back our data storage for Keycloak. All this is running inside this cluster, and this entire environment basically gives us this, it mimics our operational environment for the developers locally. At that point, carry on.
All right. Oh, hello. Okay, there we go. So you might be asking, like, what do your applications see when you authenticate, right? How are these roles passed via the JWT token to your application? So Keycloak actually is a really neat feature where you can go into any client. So in our case, we're going to look at the Grafana client. And I can take a look at the client scopes, and I can actually evaluate directly within the client itself. So I can come here, and I can select my user, and I can evaluate. And I can take a look at my generated access token. And this will actually show me the exact JWT token that's being passed to my application. So how I showed you earlier, how I was mapping myself, the admin role to Grafana as an administrator in OpenLDAP, you'll see here that under the JWT token, we've got our resource, whoops, there we go. We've got our resource access, and you can see that it's mapping Grafana, kates.neftech.com, and it's giving me the role of admin. So it's a really handy way to be able to see those JWT tokens. You can do that for any client. It's super handy. It's much easier than like creating some script to curl the token and dump it out or whatever. Super cool stuff. There is also two-factor authentication. I'm sure all of you are familiar with 2FA. A lot of companies tend to purchase products to do 2FA for you. Things like Duo can run quite the pretty penny. But Keycloak actually offers 2FA using Google Authenticator for free. So I can come to like any user, I'll use myself as an example, and I can go to the required user actions, and I can just require myself to configure OTP. And if I set that and save it, if I come to log into, or actually let me do it for Dan here. So I'm going to do the same thing, but just for Dan instead of myself. So I'm going to require him to configure 2FA. And then if I come and try to sign in as Dan, whoops, we're already signed in. There we go. So I tried to sign in again after requiring the configuration of 2FA. And now before Keycloak will let him log back in, he needs to configure dual-factor auth. And he can simply install Google Authenticator or free OTP, just scan the QR code, and he's good to go. It's free, it's easy, you don't need to pay a bunch of money or buy any third-party products. You might ask yourself, why would you use Keycloak? I personally, if you think about it, identity is kind of at the heart of everything you do. Every application you log into, every server you SSH to, all of that requires identity and access management. And putting that into the hands of third party can be very risky. You think most recently of, we can use Okta, right, kind of as a beacon of example. Okta recently had a little snafu where they were using a third-party company for their tier 2 support, and that third-party company was storing master passwords in an Excel spreadsheet. That Excel spreadsheet was compromised, and Okta, what was it, like 200?
350 something?
Yeah, they had roughly 350 clients that were compromised because of that mistake. The cool thing about Keycloak is that it runs completely locally. Nobody is in charge of it but you. It really puts the hands of identity back into, well, it puts identity into your hands rather than a third party.
And there's a couple other things I just wanted to point out here. Just so that you're aware, all of these things, we actually are developing a set of training material that leverages Jupyter Notebooks, if you're familiar with Jupyter Notebooks. But these allow you to actually, as you're learning the material, actually to run it locally on your own cluster. Run it locally, and basically we walk through the entire process of setting up this internal developer or DevOps platform that we have, including all this with Keycloak. And a couple other things I just wanted to point out where Kubernetes makes Keycloak especially nice is it comes with these great CRDs, custom resource definitions, which allow me to define Keycloak itself, realms, and clients, all from files that I can check into Git, which are fantastic. So let's take one quick look at those. Well, what time is it? Yeah, I think we're just a little bit over. But kget Keycloak in all namespaces. There's my Keycloak instance. Oh, I'm already in the right namespace. Keycloak SSO. And all that there is to define it is all of this stuff down here. And likewise, if I kget Keycloak realm, you can see we've got our LDAP realm, which defines how we do LDAP synchronization. And this is all checked into version control, so it all fits into our nice DevOps principles. And of course, finally, Keycloak clients. You're going to see our Grafana, KubeOIDC, and Oauth proxies that we showed in our demo here. And these, again, are all files to be checked in and managed just like any other resource. And that's really where, in my opinion, running Keycloak is not hard. It's typically seen as a hard thing to run yourself. But if you run it in Kubernetes, it makes everything just so much easier. So, and yeah, we didn't really focus much on the multi-tenant, but just to let you know, if I come into the main admin, which is under the master realm. I'm logged in as admin. You can see in the upper right-hand corner here. I can see all realms from the master realm. But if I come in instead to it's got an endpoint that's specific just to the LDAP realm. Well, I'm already logged in, aren't I? Let me pull up a new session here.
You're going to have to disable the OTP requirement.
No, yeah, I'll just log in as, yeah, that's right. I will, won't I? Sorry about that. Keycloak. Configure OTP, there we go. And then, yeah, thank you. I forgot to save. And then window, new tab. There we go. And now I will go to Keycloak.auth admin LDAP. So this is the admin console just for the LDAP realm. And you'll see that first off, my admin password wouldn't work. I'm not going to show you that. That's boring. Oh, it still got me on this. It still got me. Okay. But anyway, this was an LDAP realm that would just manage, I'm not going to do this setup right now, but that would manage just this LDAP realm. This now allows us to federate. And the way we use this, particularly at the company we work with now, is they have third-party hospitals that they work with, and the hospitals need to manage their own users to have access to the system. We can actually delegate the administration for the users for their app to them. And their own people can integrate it with their LDAP so they have the same single sign-on of their own users, even though they're partners with us. And it makes it seamless and easy and makes us look much more complete and professional than we would be otherwise without it. So, and finally, if you want to see our GitHub on here, we've got this, they'll all be in the notes as well when the slides come out. But yeah, we've got this GitHub directory that goes through all of our public notebooks. Come take a look at them, come run them. Please give us feedback. We're trying to flesh them out so that you can show it on Windows, Mac, and Linux, that you can set up clusters in any of the major cloud providers, Minikube, Rancher Desktop, Docker Desktop, or KOS. So basically kind of covering the full gamut and give you the same experience no matter where you are. So.
Cool. Thank you guys again. Does anybody have any questions for us? I know we covered a lot in a very short amount of time.
When you logged in with kubectl, were you mapping to a cluster role when you did that?
Let me show you that just real quick. So yeah, we have hold on a second. Let's see here. Kget cluster role binding, sorry, let me spell right, grep on OIDC. So we have a OIDC admin group, so we've logged in, and that's what maps in our role in a token that, as the admin group, and then we bind that in here. Yeah, let's create, edit, and then if I take a look at that guy, you can see the actual contents of it. We have a field in the JWT token that is prefaced with OIDC group : and the role I'm binding to it is developer, which is the role that I've got in the system, and that will then bind me to the cluster role admin. You can of course set this up as a role binding to have it to one namespace, or yeah, and this allows us basically to do all our RBAC through, we do it through our GitLab, we use our GitLab groups. And our GitLab runners will deploy to different clusters depending on which runner you choose and which group you're in. So basically, our GitLab groups define our access to the clusters. And so we map GitLab groups at our corporation to access privileges in each cluster. So we got one more over here.
What Cube OIDC proxy are you using? Is it the one from?
They're all in the links again, but one more, here we go. So first off, Cube Login is the plugin to Cube Control. JetStack makes Cube OIDC login to Cube OIDC proxy, which is proxying to the Cube API. And then Oauth 2 proxy is another CNCF project that provides a identity-aware proxy so that you can add transparent auth to third-party apps. And of course, Keycloak itself. And yeah, with the backing of IBM and their commitments, well, not theirs, maybe more Red Hat's commitment to open source, it's not going away. It's a fantastic product. It's one of those few products that the more I learn about it, the more delighted I am with it. It's complex, it's a beast, but OIDC and authentication can be a beast. If you follow through hopefully with our notebooks, we help use that path and hopefully kind of make that path a lot easier for everyone. So,
anybody else? Excellent. And so can we have a big round of applause for you guys?